I'm going to measure, take the take the sample and measure the mass and record the mass. And so I try to write something out as a list of things that you will be doing in the correct order there. Just like the one that I gave you for the density lab. So you obtain the sample, you record the mass, you do the measurement, you calculate the volume, you determine the density, and that kind of thing. Okay, so when we ask you to write a procedure, and that's what we mean, that's what we need. And when you come to the lab there, we will check the procedure, we'll sign it, and we'll give it back to you. Now hold on to that signed procedure because that's part of your work that you need to turn in. And when you turn in the lab report, when you finish everything, you need to attach a cover page, the signed procedure, whatever data you obtain from the lab activity, and showing the calculation. If there is a requirement to write a brief summary or discussion, then include that in there as well. So that's how you're going to do the lab work there. And some of the lab activities there, and one like the experiment that we're doing today and on Thursday, and it's very time consuming because it involves heating a sample with a Bunsen burner, and then we require you to measure the mass of the sample. Now you can't measure the sample when it's hot, so you have to cool it down. And cooling after heating on an open flame there will take forever. So each cooling process takes about 15 to 20 minutes, and we have to heat it twice, meaning we have to cool it down twice. So that alone can be an hour-long process there. And on top of that, you have to measure the mass, and you have to do the calculation and all that. And at the beginning of the lab today, there is also a quiz. So, and I probably will need to spend a good 15, 20 minutes talking about the safety issues involved in this lab activity. So that's the reason why we extend the hours for the lab back to the 3-hour time frame there. Okay. So in terms of the lecture there, we were pretty much halfway through the chapter 3 there. Now again, there is a section in chapter 3 that I did not spend a whole lot of time talking about, or at least I went through it very fast. And what I want you to do here is that's the nomenclature part of the chemical compounds. And so you need to pay attention. And eventually, this is the slide that we want you to focus on. And this pretty much summarizes how you name a chemical compound when the formula is given. Looking at the elements involved in there, whether it's ionic or molecular, or whether it's an acid with oxygen or without oxygen. And this table basically summarizes everything that everything that you need to know on how to name a particular chemical compound. So this is something, in addition to all that slides that we went through there, this is something that we want you to take a look at. And this gives you the basic format for how we come up with the name of the compound there. Okay, so it's very important that we know these basic rules for nomenclature, because when you deal with chemicals there, when you deal with different matters there, you do need to know what their names are. And just like when you try to get to know a person, the first thing you want to know is what's their name. Okay, so how do you name compounds there? And that's kind of important there. And however, these rules are fairly how should I put it? It's something that you need to memorize. And when you memorize these rules there, when you see a compound and try to give it a name and double check and make sure the name is correct, and only through that repeated back and forth practice, you will get to know how to name a particular chemical compound. So this is very important. And always remember, when we're talking about the chemical, the formula that we're talking about there, the formula has a fixed ratio of the elements involved in there. Okay, so H2O is different from H2O2. So when you change the ratio of the elements involved in there, you have changed the identity of the chemical there. So this particular slide is something that the flow chart. This is something that we want you to focus on when you try to name a particular compound. So you have to categorize them either ionic, molecular, and then there's another type of compound acid, and of course there's base in there. Okay, and the name of the base is very much similar to naming the ionic compounds of naming ionic compounds there. So those are the things. Again, we do not spend a whole lot of time in class, but this is something that you definitely need to pay attention to. Okay, and so that's our first learning objective in chapter 3. And remember, chapter 1, chapter 2, we introduced the basics of chemistry there, and we talk about the definition, we talk about the dimensional analysis. And then chapter 2, we start to give you an overview of the periodic table and trying to show you the organization of the periodic table and giving you the alphabet for the language of chemistry. And then chapter 3, we're trying to piece all those alphabets together and try to come up with spellings, the word, and the name of the compounds. Okay. And then in the first part is nomenclature. And the second part here, given a formula of a compound there, we need you to be able to quantify the amount of chemicals. And we talked about that at the end of chapter 2 for the calculation there. And we introduced the quantification part of the periodic table. And everything that you see in the periodic table, the atomic mass, is something that you can use to determine the molar mass. Now, if you have the molar mass there, and if you have the mass of the sample, we can determine how many moles of the sample in there. So here, given the formula of compound, using the molar mass of the elements there, we need you to be able to calculate the percent composition for each of the elements there. So we need to know not only what is in a particular compound. Given the formula, you can tell what's in there. We also want to know how much of each is in there. So that's what this particular learning objective is all about. And given you, say, for example, ammonia, NH3, or water for that matter, H2O, how much, in terms of percentage, how much of ammonia is nitrogen? How much of it is hydrogen? Well, we do a calculation there, and we say, well, 82.244% of NH3 molecule is nitrogen in terms of mass. So 17.755% of ammonia is the mass is hydrogen. Now, how do we come up with these numbers? Well, in this case, and the percent composition by mass, well, percent composition of anything would be the mass, the percentage of the a particular elements in a compound by mass, and that should be the mass of that particular element divided by, in 1 mole of compound, divided by the molar mass of that compound there. So for ammonia, how do we come up with that 82% and 18% there? Well, if you look at the molecule of ammonia, for each mole of ammonia, it weighs 17 grams. How do I get this number? Well, nitrogen is 14. Where do you get the 14? Periodic table. Okay, hydrogen is 1 times 3. So 17 plus 3, 14 plus 3 equals to 17. So the molar mass equals to 17 gram per mole. And the percent of nitrogen would be 14 gram over 17 gram. That is, in every mole of ammonia, you have 1 mole of nitrogen. 1 mole of nitrogen weighs 14 grams. 1 mole of ammonia weighs 17 grams. And multiply that by 100, and that will give you roughly about 82%, 82.244%. So this is how we do the calculation. This is the equation that we need you to remember. And same thing that for the